Assalamualaikum to my lecturers, the Ikwan, and my fellow friends. Today, our group want to present sustainability and green engineering for electric vehicle. Before I start, I want to introduce myself and my group member. My name is Muhammad Shafiq Sharul bin Rodin. My metric number is 07 DKM21F2006.
My name is Muhammad Ikhwan bin Sulaiman. My matrix number is 07 DKM21F2032.
Hi, my name is Aiman Hafizuddin bin Abdul Wahid. My matrix number is 07 DKM21F2034.
My name is Muhammad Dizul Fadli bin Muhammad Saleh and my metric number is 07 DKM21F2022.
Table of content. First, we have introduction. Topic background, initiative and policies related incentive. 2. Findings. The acceptance of technology, including statistical graph and etc. Related current issue. Number 3 is discussion. Summarize the finding, identify alternative solution to this major problem, briefly outline each alternative solution and evaluate its advantage and disadvantage, and the last is conclusion.
Sustainability in electric vehicles. Reduce emissions. Electric vehicles contribute to sustainability by producing fewer or zero tailpipe emissions, especially when charged using renewable energy source. Number 2, material and manufacturing. Green engineering principles focus on sustainable material and eco-friendly manufacturing process in the production of electric vehicle, minimizing environmental impact. Number 3, life cycle analysis. Sustainability consideration extend beyond driving. Life cycle assessment evaluate the environmental impact of electric vehicle from manufacturing to disposal, guiding improvement in each phase. Green engineering in electric vehicle. Number 1 is efficient battery technologies. Green engineering principles drive research into developing more energy efficient and environmentally friendly battery technology, considering factors like resource use and recyclability. Number 2 is recyclability and end of life management. In mind, ensure that materials can be reclaimed at the end of a vehicle's life, aligning with sustainable practice. Next, lightweight materials. Incorporating lightweight yet durable materials in vehicle construction enhance energy efficiency and reduce the overall environmental impact during manufacturing and operation. Initiative and policies. Number 1, renewable energy credit for charging station. Initiative may provide renewable energy credits or an incentive for business and individuals who install and use renewable energy source for electric vehicle charging stations, encouraging a greener charging infrastructure. Next one, sustainable public transportation initiative. Policies may focus on integrating electric vehicles into public transportation fleets, promoting sustainable practice in mass transit and reducing overall emissions in urban area. Last one, eco-friendly vehicle fleets. Policies encourage government agencies and business to transition their vehicle fleets to electric or hybrid options, promoting sustainability and serving as a model for broader adoption.
Next is relative incentive. So first is eco-friendly driving incentive. So insurance companies or local authorities may provide incentive for adopting eco-friendly driving habits. This can include reduced insurance premiums or other peaks for electrical vehicle owners who demonstrate environmentally conscious driving practice. Next is grant for sustainable charging infrastructure. Governments and municipalities may provide grants or subsidies to businesses and individuals for installing sustainable and energy efficient charging infrastructure. This encourages the development of green charging solution and supports the overall sustainability of electric vehicles. Last but not least is recognition programs. Some regions have recognition programs or certifications for environmentally friendly vehicle. Owners of electric vehicle may benefit from special privilege such as preferential parking or access to restricted zones as a reward for contributing to sustainability and green engineering practice.
For the findings, the first one, the acceptance of technology. The electric vehicle runs on electricity alone. It is powered by electric propulsion motors that use the energy stored in a battery. There is no internal combustion engine, fuel tank, fuel pump, or fuel line. To recharge the battery, it needs to be plugged into a charger. It does not emit tailpipe emission because it runs entirely on electricity. From figure 1, we can show that Malaysia's annual electricity generation and maximum demand projection. The number of cells is increasing rapidly every year, and it is expected to increase steadily for 5 to 10 years. The increase in cells volume will decrease the market price soon. With the decline in battery price, the related cost of an electric vehicle will also continue to drop. However, any innovation in the battery technology should be backed by sophisticated technological competency, chemical potentiality, scalability, and space for further improvement. From figure 2, we can show cells of electric vehicles globally. Next, for the related and current issues, the first one based on the NFPA 2020 by 2040, all internal combustion vehicles will no longer be incentivized. The incentive will only be given to electric vehicles, full cells car or other environmentally friendly green cars. Second one is high market price. The electric vehicle price in Malaysia is expensive. Compared to the conventional car, the cost of an eco-friendly vehicle, for instance, might be 1.5 advance is 23.7% cheaper than Mini Cooper SE with almost the same body structure. The third one is travel demand, battery capacity. Since EV run on electricity, range anxiety is one of the driver's most significant concerns. The drivers must ensure that the EV is fully charged before going out for their next long drive. This limited capacity of electric batteries reduces the driving range. It makes the consumer disinterested in owning an EV since, in some cases, drivers might need to reroute from their original travel trajectory to refill their batteries. And the fourth one is charging infrastructure. The lack of availability of charging stations along the driving path is another core issue for EV users. From the figure, we can show that distribution of charging stations in Malaysia. We can see that there are not many charging stations in Malaysia, especially in Borneo. We can see only in Sarawak have one.
So next we go to why EV accepted in sustainability and green engineering. So first is EV has zero. So next we go to why EV accepted in sustainability and green engineering. So first is EV have zero carbon dioxide emission during operation suggests that these vehicles are very eco-friendly. The second is the world primary modes of transportation are facing two major problems. So first is raising oil costs and increasing carbon emissions. As a result, electric vehicles are gaining popularity as they are independent of oil and do not produce greenhouse gas. So thirdly is EV can reduce urban air pollution by using renewable energies, including solar, hydro, wind, and nuclear. Plus is smooth and quiet operation. EV operation significantly more quietly and smoothly than conventional cars because electric motor generate less vibration and noise. This may result in a more relaxing and pleasurable driving experience. And last is performance. Electric motors can produce instant torque, allowing EV to accelerate quickly. They could also having a lower center of gravity, making them more stable.
Summarize the finding. Electric vehicle or EV optimize sustainability and green engineering, aligning with eco-friendly principles throughout their life cycle. From government mandate encouraging zero-emission vehicle to financial incentive promoting green technology adoption, policy drive the shift toward a sustainable automotive industry. Initiative focus on renewable energy, emission standard, and research funding for green engineering innovation, fostering energy-efficient batteries, lightweight material, and eco-conscious manufacturing. Charging infrastructure, expansion plans, and public transportation initiative further solidify electric vehicle as a sustainable green transportation solution. This collective effort reflect of a global commitment to reducing environmental impact and advancing green practice in evolving landscape of electric vehicle. Identify alternative solution to this major problem. Number 1, battery production and recycling. Problem: the production of electric vehicle batteries involve resource intensive process and poses challenge in recycling, leading to environmental concern. Number 2, rare earth element dependency. Problem: electric motor, particularly those used in EV, often rely on rare earth element which can have environmental and ethical implications in terms of mining and supply chain practice. Number 3, limited range and charging infrastructure. Problem: the limited driving range of some EV and the efficient charging infrastructure can contribute to range anxiety among consumers, hindering widespread adoption.
Alternative solution: battery production and recycling. Alternative solution: invest in the development of more sustainable battery chemistry such as solid-state battery or lithium-sulfur battery, which may offer improved environmental profiles and easier recycling. Next, rare earth element dependency. Alternative solution: research and implement alternative materials for electric motor components that don't rely heavily on rare earth elements. Exploring innovative designs that maintain performance without this scarce resource. Number 3, limited range and charging infrastructure. Alternative solution focus on research and development to improve battery energy density, allowing for longer driving range. Simultaneously, accelerate the expansion of fast charging infrastructure to address range anxiety and promote convenient charging.
Briefly outline each alternative solution and evaluate its advantage and disadvantage. Number 1. Alternative solution for battery production and recycling. Outline develop solid-state batteries or lithium-sulfur batteries to replace traditional lithium-ion battery. Advantage: potential reduced environmental impact, easier recycling process. Disadvantage is current alternative may face challenge in terms of scalability, cost, or technological maturity. For number 2, alternative solution for rare earth element dependency. Outline, research, and implement alternative materials for electrical motor component. For the advantage, mitigates environmental and ethical concerns related to rare earth element. For the disadvantage, finding suitable alternative may require significant research and performance might not match that of a rare earth based on component.
So for last is alternative solution for limited range and charging infrastructure. Outline is invest in R&D to improve battery energy density and simultaneously expand fast charging infrastructure. So for advantage is addresses range anxiety, promotes convenient charging. So for disadvantage, research and development can be resource intensive and infrastructure expansion requires significant investment. So lastly, from this topic, we summarize electric vehicle bring together sustainability and green engineering for a cleaner transportation future. While challenges exist, ongoing efforts from better batteries to ethical sourcing shaping a more eco-friendly automotive landscape. This commitment to green practice highlights electric vehicle as key players in creating a sustainable and cleaner way to travel.